All right, in this video, I am going to do the entire curve sketching algorithm for this equation over here, this rational function, and I'm going to do it without a calculator because a calculator is not allowed in the course that this student is taking. So let's start with just finding the x and the y-intercepts. These are not necessary, but because it's in factored form, it's really easy to find the x and the y-intercepts. For the x-intercepts, I'm just doing the solution to the numerator. So x is just equal to 5. And for the y-intercept, I'm just subbing in x as 0. So I have 0 minus 5 over 0 minus 3 squared, which is just negative 5 over negative 3 squared, which is just negative 5 over 9. Next, I'll do the asymptotes. So for the vertical asymptote, it's just the solution to the denominator, which is x equals 3. And then for the horizontal asymptote, the degree on the top is 1 and the degree on the bottom is 2. So when the degree on the top is less than the degree on the bottom, basically x divided by x squared in this case, we always have a horizontal asymptote of y equals 0. So next, we will derive our equation to find the critical points. To derive this equation, I have to use my quotient rule. So f equals x minus 5, g equals x minus 3 squared, f prime is just 1, g prime is just 2 times x minus 3, and then it would be times 1, but I don't really need that. And then I'm putting in my quotient rule, which is f prime g minus g prime f divided by g squared. So let's sub this in now. F prime is just 1. G is x minus 3 squared, so 1 times x minus 3 squared, basically that times that, minus g prime times f divided by g squared. So g is x minus 3 squared. If I square that, I will get x minus 3 to the power of 4. I want to simplify this. In order to simplify, I'm going to common factor out x minus 3. And if I common factor that out, I'm just left with x minus 3 minus 2, x minus 5. I basically took out an x minus 3 from each of these two terms. Bottom still stays the same right now. And now I can cancel this out and turn that into a 3. I can also expand the inside over there. So don't need a bracket on the top anymore. I'll just write it as minus 2x plus 10 divided by x minus 3 cubed. Combine like terms in the top. So that's just negative x plus 7 over x minus 3 cubed. So this is my simplified derivation over here. Going to make this equal to 0, solve for the critical points. When I make it equal to 0, I can just cross multiply that. It just disappears. Anything times 0 is 0. So I just have 0 equals negative x plus 7. Move the negative x to the other side. So x just equals to 7. So this is my first critical point. Once I find the critical point, I have to do my intervals of increase and decrease. And I have to classify this critical point. In order to do that, I'm going to use a number line. You can use a sign chart as well, but I find number lines a bit quicker. On your number line, you want to include all critical points and all vertical asymptotes. So I have 3 and 7 over here, and now I want to test each interval. I'll start with the interval on the left over here. I'll just pick a 0 over there. So f prime of 0, I'm just subbing in 0 into this equation. So on the top, I'll just get 7. And on the bottom, I'll get negative 3 cubed. That's a positive over a negative number. You don't need the actual answer. Positive divided by a negative is just negative, which means that this interval right there is decreasing. Pick a value between these two, so I'll do f prime of 5. Negative 5 plus 7 is positive 2. 5 minus 3 cubed is 2 cubed. Positive divided by a positive is just a positive, which means that this is increasing. And then pick a value over here. We'll do f prime of 8. So f prime of 8, if I sub into this equation, on the top I'll have negative 1, and on the bottom I will have 5 cubed. Negative divided by a positive is a negative. Means that this is decreasing again over there. So now we can classify our critical point at x equals to 7. Remember, that's a vertical asymptote. No need to classify that. But this over here, we can tell is a maximum. So we have a maximum, and the x value is 7. To find the y value, I'll sub it back in the original equation. So f of 7 equals 7 minus 5 over 7 minus 3 squared, which is 2 over 4 squared, which is 2 over 16, which simplifies to 1 over 8. So our maximum is just 1 over 8. Now that we've done that, we can come back to the first derivation. We can find the second derivation. Also, if you want to write your intervals of increase and decrease, we can do that as well. So my intervals of increase are just from 3 till 7. And my intervals of decrease are from negative infinity to 3 and from 7 till infinity. So let's do our second derivation now. Again, I'm going to use the quotient rule over here. So f equals negative x plus 7. G equals x minus 3 cubed. F prime equals negative 1. G prime equals 3x minus 3 square times 1 with the chain rule. So we don't need that. So let's put this in my quotient rule again. So f prime times g, so that's negative x minus 3 cubed minus g prime 3x minus 3 square f, which is negative x plus 7. And then what I want to do is I want to divide this by g squared, which is x minus 3. And now the exponent becomes 6 if I square that. Now we want to simplify this. So we want to common factor. I'll grab another sheet here because I'm out of space. So I can common factor out, I guess I can common factor out x minus 3 squared. And then I'll be left with negative x minus 3 minus 3 negative x plus 7. Denominator stays exactly the same, x minus 3, 6. I can cancel this and turn that into a 4. I can also simplify the inside of this bracket over here. So that's just negative x plus 3 plus 3x minus 21 divided by x minus 3 to the power of 4, and combine like terms over there. That's just 2x minus 18 over x minus 3 to the power of 4. So this is my fully simplified second derivation right over here. I'm going to make it equal to 0 and solve for my inflection points. Again, the bottom just cross multiplies and disappears. So I just have 0 equals 2x minus 18. Move that to the other side. So 18 equals to 2x. Divide by 2, which gives me x equals to 9. So this is my x value of my inflection point. To find the y value of the inflection point, I'm just going to sub in the x value back into the original equation. So f of 9 equals to 9 minus 5 over 9 minus 3 squared, which is 4 over 6 squared, which is 4 over 36, which just simplifies to 1 over 9. So my inflection point is 9 comma 1 over 9. Finally, I can do my intervals of concave up and concave down. So I'll do a number line for that again. On the number line, you want to include the inflection point and you want to include the vertical asymptote as well. So over here, I have 3 and 9. I'll start by subbing in the first interval over here. Remember, I'm doing this in my second derived equation. I'll start by picking f double prime of 0. That's just negative 18 divided by negative 3 to the power of 4, which is a negative divided by a positive, which is just a negative, meaning that this is concave down. Pick a value over there. I'll do f double prime of 5. 2 times 5 is 10. 10 minus 18, that's negative 8. The denominator is 2 to the power of 4, which is basically a negative over a positive, which is again a negative, which means that this again is concave down. And finally, I'll pick a value out there. I'll do f double prime of 10. So that's 2 in the top, and in the bottom I have 7 to the power of 4, which is a positive divided by a positive, which is positive. So finally we are concave up in that final range. So I'll do my intervals of concave up and concave down next. Concave up from 9 to infinity. Concave down from, oops, I don't know why I wrote 0. Concave down from negative infinity to 3, and then from 3 till 9, so 2 intervals of concave down. And finally, I'm going to sketch this out. I know, a really long problem, lots of information, but let's sketch this out, put all the information that we have on this. Really easy to do the sketch, honestly. I'm going to start by just drawing your vertical asymptote and your horizontal asymptote. It's y equals to 0 and x equals to 3. You can label your x and y intercept next, because the x-intercept was 5 and the y-intercept was negative 5 over 9. So negative 5 over 9 and then 5 over there. I'll label the values a bit later once I do the graph, so it's a bit more neat. Then we want to do critical points. We have one critical point here in this question. Was a maximum of 7 and 1 over 8. So 7 and 1 over 8 is 3, 5, 7, somewhere over here. And then we have an inflection point at 9 and 1 over 9, which is basically like somewhere over there. Again, this is just a bit approximate. So this is what we have over here in terms of the information. So how can we draw this? Well, let's look at this part over here. We know that this entire area is concave down because from negative infinity till 3, it's concave down. We also know that it's decreasing as well from negative infinity to 3. So if this is all decreasing and concave down, there's only one possible thing we can do to draw it, and that is it's going to be hugging the horizontal asymptote. It's our y-intercept, and it's concave down the whole time. It's decreasing the whole time. I can label my point over here now, my y-intercept, negative 5 over 9. Then from 3 till 7, from here to here, it's increasing, but it's also concave down from 3 all the way till 9. So from here to here, it's increasing. It means it has to be coming like this. It's also concave down. And then after this, from here till infinity, it's decreasing again. So as we can see, from 7 to infinity, it's decreasing. But from here till here, it's still concave down. So that's concave down and decreasing in that tiny range. And now it's going to switch after the inflection point concave up, but it's still decreasing over here. We're just going to hug the asymptote. So that's what the graph would look like. I can label the rest of my points now. That's a 5. That's my maximum, which was 7, 1 over 8. And that is my inflection point, which is 9, 1 over 9. That is all the information used to draw this graph out. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.